Hi, my name is Sidhartha Dash, or Sid Dash for ease of pronunciation and simplicity. I'm the research director at Chartis, and today we are going to discuss practical applications of AI and advanced statistical techniques in managing and handling complex securities and financial products. Uh, with that, for that, I have Suhrud from RiskSpan, who will introduce himself.
Thanks, Sid, and thanks for giving me the opportunity to join you in this discussion. So my name is Suhrud Dagli. I'm one of the founders of RiskSpan and manage our platform business. RiskSpan is a data and analytics company. Our expertise is in managing large data used for managing risk and investment for securitized product portfolios.
Thanks. And as usual, as you all know, we would like to, we'd like to think about how is AI applied in different parts of the financial spectrum. Where is it finding appropriate application, and what are the right contexts? With that in mind, one of the areas where we think there are some really interesting applications is the idea of leveraging AI for data management, particularly in handling complex and very large sets of data. How do you guys, use AI in a data management context, if you will?
Yeah, so that is our number one use case for AI, and just like several other companies who've been working on large, messy data problems, we've been working with AI and machine learning algorithms for several years in that space. Since the Gen AI models have become more readily accessible, the type of work we can do or the type of efficiency we can provide to our users when it comes to data management has improved a lot. Because if you look at the large language model and the Gen AI systems that are available, like large companies have been leveraging these systems for a while now, but in our space, in the investment and risk management space, where precision is, more important than creativity, the adoption has been taken longer because it's been too expensive. Large companies like BlackRock and Goldman Sachs of the world, they have invested and they've used their resources to build these models. But now, all of us can do the same thing. So where we see is one is data mapping. So in our world of securitization, the collateral data comes in various forms across various asset classes. Even something as simple as how do you identify a value, whether it's a credit score or FICO or borrower score, et cetera. Like how do you normalize that? So something as simple as that to imputing missing data. If the data is missing, like what do you how do you impute it and how do you correctly apply that? So we have had an implementation of the data normalization module for some time now, and it has the success rate and efficiency has improved exponentially since we started using some of the Gen AI models.
And one of the things that we hear all the time with as we talk to vendors, end users of these models, and so on, that a lot of the improvements is about doing it and doing it again. This is a learning by doing exercise. Calibration is as important as design, and so on. How do you react to that, and what do you think about that, if you will?
No, that's a really good point. So it's the whole idea of getting better and more training data definitely improves the algorithm. But I think what Sid you are referring to is even more than that, is that how do you even select your algorithm and calibrating our algorithm, or even using multiple algorithms for different use cases. And that is definitely more than just feeding more data through the process. everything from the type of information that comes through the user interaction with the data and mapping, we've learned is as we see more asset classes, more types of users, types of data, and types of application, we've been tweaking and tuning our algorithm a lot. But what's also happened with these Gen AI models, and especially the code generation aspect of those models, that interactivity and iterative aspect of calibrating the algorithm has become instantaneous. You've kind of taken out the human element of writing requirements, writing code, testing it. You can do this more iteratively and interactively, and that is really making a big difference in taking more data in and learning rather quickly through the process.
So it means that the iterations are now are faster, and your calibration cycles are quicker, and so on and so forth.
Correct. But nonetheless, very critical. It's not one of those things that you build it and forget it, for not at all.
Absolutely.
Yeah.
Absolutely. I mean, some people think of these tools as single silver bullets, but no, they are bullets that have to be continuously carved and refined and kept in shape, and so on and so forth.
Exactly. Even like simple things like how you present the data to these models, it matters, right? So if you want to identify whether a loan is a loan for a residential property or a commercial property, how you feed in the property type field, you want to feed that first, but not the other fields. Like all those things really matter to these models, and you only learn that by just being more iterative and through the process.
In many ways, doing the activity is the IP.
Yes, that's right. That's right. That's exactly that is exactly right.
So now, sort of moving from the core sort of data management example, and as we can see, it's A, not trivial, B, there's a lot of work, and C, there's a lot of upside and benefit, and it's a very practical and pragmatically real area. But having said that, if we move from there to maybe other areas that you would be potentially looking to apply this kind of technology, perhaps in scenario management, et cetera, et cetera.
Yeah, so that's, again, I think scenario management and even responding to moves in the market or macroeconomic changes is another big area. And that's one area where I think some of the really very sophisticated large firms have had this ability for some time, and now again, it's becoming more accessible to the rest of the investment world. So it's things like when you're looking at a economic environment or a regime, trying to find other times in the past where a similar environment or regime might have existed, and while considering different macroeconomic variables, right? So it's not just inflation on its own, but inflation with different interest rate environment, different housing environment is something that kind of and on the surface it seems pretty easy because it's a matter of creating a database where by and putting various constraints around that, but it's where this gets complicated is, number one is again because of data. So like having clean data or data where what the data's constraints are from a time series perspective, and and all the macroeconomic data that you collect over time is critical. And then also looking at the correlations and the and correlations changing over time is also critical. So in the past, even thinking about this and putting this together would require writing requirements and writing code to build something like this. And you typically build it for a narrow set of variables. Whereas this use case, what you can do today with Gen AI is that you can take a lot of data, you can take disparate data and have these models generate code to solve that specific use case. Of course, I'm completely putting aside the whole validation aspect. That's a whole nother thing that you need to worry about, and more so now than ever. But this ability to again bring in various data sets that might be available today, may not have been available, several years ago, and then using that to create scenarios that are relevant for today's investment portfolios and today's environment is also a use case that we've been using a lot. Our work started during COVID, where we were facing an environment that had never existed before, and a lot of data got available. But now it's evolved as we again are sitting in a very different, unique economic environment.
No, of course, and again, Ken, I think this is a problem of details,
Yes.
how you map, how you structure the problem, and so on.
Yeah.
Structurally, and pattern sort of is emerging, if you will. Leveraging AI requires attention to details of the problem.
Correct.
And there are very few problems which have as many details as securitization, if you will. But moving from there to another area, how do we think about using AI techniques in, say, things like model validation, etc., model risk management, model risk analysis?
So I think what AI has done, or at least where we are seeing applications and benefiting from it, is really understanding the limitations of a model. Are there areas, error spaces where the model doesn't necessarily today do a good job predicting or forecasting what it's meant to forecast? And are there areas where the model hasn't seen enough data to do a good job and be more accurate? And because it's like all models where there's a lot of data do a phenomenal job, but it's not always apparent where they have errors or sparse data. So that's where we are using AI techniques to do a few things, that letting our users know where the model is better fitted than other areas. Also helping calibrate the model or impute data to help the model become better. And then finally, also using some of those simulated data sets to test the model and validate the model. So I think those, because even, even just goes back to 30 years ago, where, there was a trader who had decided to buy a bond based on a single value, an OS value that just seemed really cheap. But the prepayment model, which was driving that securitization value, was not functioning well for the interest rate that the underlying loans were consisted of. So even through then, so even now, right? Market, if people just make decisions on single numbers, you do need to look at the model fit and not just on an average, but the collateral that's really impacting your analysis or the use case where you're using the model. So I think that's where we are benefiting quite a bit, and we believe that model validation effort will also be benefited by these models. There also, we've had some conversations with some regulators about the use of AI models to kind of to build a model from ChatGPT, write the code, create documentation, create validation documentation, and how do you validate such a model? That's a whole another thing. Where, as you said, again, there's a lot of details to be covered here.
Great, thank you. So I think we covered a lot of interesting ground. We discussed, I think, the challenges, solutions, and dynamics of leveraging AI for mapping and data management, and some of the details that securitization type problems bring to the table. We also looked at, I think you sort of took us over a few issues around details around statistical techniques and mapping, leveraging AI in complex scenario management situations, and finally looked at some of the, analyzing details in model risk. With that, I think we bring this hopefully the discussion to a close, and hopefully we brought out a few interesting, pragmatic areas where AI can and is being leveraged. Thank you.
Great. Thank you very much.